We'll take a quick look at integrals starting at negative infinity instead of going all the way to positive infinity. It's the same basic idea. You say, well, it's the integral from a to b, which is already well defined, and then let a go to negative infinity. Here's a quick practice problem you could do. It's basically the mirror image of what we just did. But the more interesting, more complicated thing is integrating from negative infinity all the way to positive infinity. So here's an example that's interesting. This function looks like a classic bell curve. It's not quite the same as the classic bell curve in statistics, which is e to the negative x squared plus some other stuff with some other stuff. But this one is also useful. It's called a logistic distribution. And we might want to know, is the total area under that 100%, or you could say 1.0 instead of 100%. So to do an integral from minus infinity to positive infinity, you have to break the integral somewhere along the real line. Usually it's 0, but it doesn't have to be. So here we're using c as a position along the real line, and you integrate from negative infinity up to c, and then you stop, and then you integrate from c up to positive infinity, again using limits the way we did for the one-sided infinity problems. And you need both of these to give you convergent answers. Then you can add them and say that's the value of this. If one or the other or both of these diverge, then you can't just add them and say the result is whatever you get by adding them, because you can't really add divergent things. So let's actually try this problem. How would you, first of all, where would you break this? And how would you integrate it? Well, I said we often break at 0, or we often break wherever there's a line of symmetry, and there's a line of symmetry here at 0. So we'll say, let's use c equals 0. Before we worry about all the limits and stuff, let's just do the indefinite integral first, so we get a formula that we can then plug in. So we'll say, let's use the indefinite integral. So what's the indefinite integral of e to the x over 1 plus e to the x squared dx? How would you do that problem? Trig substitution, trig identities, u substitution, integration by parts. I think u substitution, just u equals 1 plus e to the x, du equals e to the x dx. And then we'd get, so 1 over u squared, and then e to the x dx is du. And we can write 1 over u squared as u to the negative 2. And then take the integral, you get 1 over minus 1 u to the negative 1. And then we're going to ignore the plus c because we're going to be plugging in stuff later. We'll just simplify that, and we get 1 over, the u to the negative 1 is 1 over stuff, so 1 over 1 plus e to the x. And then let's say the doubly infinite integral is the integral from minus infinity to 0 plus the integral from 0 to infinity. So that will be the limit as a goes to minus infinity of this thing. We'll do that from a to 0 plus the limit as b goes to infinity, of minus 1 over 1 plus e to the x 0 up to b. And then what will we do? Just try plugging in the 0 and the a. We can move this minus out in front. So limit a to minus infinity, plug in the 0, you get 1 over 1 plus e to the 0 minus 1 over 1 plus e to the a. Move the minus out front here. Plug in the b, you get 1 over 1 plus e to the b minus 1 over 1 plus e to the 0. And now what? It helps me to think of this as kind of plugging in minus infinity. Well, first of all, what is 1 over 1 plus e to the 0? E to the 0 is 1, not 0. So we're getting 1 over 1 plus 1 there. Here we'd get 1 over 1 plus e to the minus infinity if you plugged in the minus infinity, which you're really not supposed to do. So we'll put kind of quote marks around it. And then this again is 1 over 1 plus 1. And plugging in the infinity, we'll get 1 plus e to the infinity. And put quote marks around that. And it's 1 over 1 plus 1. And then what? Minus, this is a half. And then what is e to the minus infinity? That's e to a very strong negative number, so that's going to be basically 0. So that's 1 over 1 plus 0. And then this is, what's e to the infinity? Well, e to the 10 is already pretty big, e to the 100 is huge, e to the 1000 is more than Excel can calculate, so e to the infinity is infinity. So we get 1 plus infinity there, minus 1 half. And then what is this? That's a 1. So 1 half minus 1. And this is, what's 1 over infinity? Well, what's 1 over infinity? Because adding 1 to infinity doesn't really do much. 1 over infinity is basically 0. So overall, we're getting minus 1 half with a minus here. And we're getting minus a half, so it's a half. And then the big question, are we actually allowed to add these? Well, both limits exist. They both give single numeric finite values rather than zooming to infinity or oscillating without settling down. So the limit exists here. The limit exists here. So it's okay to add them, and you add them and you get 1. And we were wondering, is this total area under the curve 100% or not? And it is apparently 100% or 1.0. So everything worked out nicely here, which is good news because that integral is one that we really want to have working in some parts of statistics. So the next video we'll do something and we'll see if everything works out there. Let's just show that last bit there.